Alright, so yesterday we did the law of sines, yes, which is what you were just doing. And we talked about those 4 cases that you could be given when you're trying to solve a triangle. And yesterday we talked about case 1 and 2. So that's where they gave you like 2 angles in a side or 2 sides in an angle, and you had an angle inside that were like paired up with each other. There's 2 other cases, 3 and 4, that we didn't touch yesterday. We're going to learn how to deal with those today. So again, those are on your paper right here. And you're going to use your law of cosines for that. So this is your law of cosines right here. So it's kind of repetitive, but basically you can just figure out what one side is. If you square and add the other 2 sides, and then you subtract the 2 sides that you like, the other side's the one you're not trying to find, and then the angle of the side that you are trying to find. It looks a little complicated, but the more you do it, it's really not that bad, I promise. And there's not really any need for you to memorize all 3 of these separately, because it's the same thing. You just need to know whatever angle you have here, that's the side that you're trying to find out here. Does that make any sense? Okay, so we're going to do some. So looking at the first one right here, we're given all the sides, and we want to find all our angles. So we're going to go ahead and draw this triangle, get that going. So we've got A, B, and C. They tell us that side A is 3, side B is 4, and side C is 6. So we're going to use our law of cosines to find all our angle measures. So let's just start with angle A. Is that okay? All right, so we're going to use this first one up here. That A squared equals B squared plus C squared minus 2BC cosine of A. So we'll say that 3 squared, because that's our squared. I should actually write that. That's our side A. So 3 squared equals B was 4. So we'll say 4 squared plus C squared, which is 6 squared, minus 2 times B, which is 4, and C, which is 6. And all that is times cosine of A. And that's what we're trying to find there. Are we okay with plugging in there? We just use this formula over here. Yeah? Questions right now? Okay. So then we'll start to simplify from there. So 3 squared we know is 9. And then we can go ahead and do 4 squared plus 6 squared. What is that going to be? 52 minus, what is 2 times 4 times 6? 48 cosine of A. So this is where people typically make mistakes. They try to do 52 minus 48, but that 48 is attached to the cosine, so we can't do that. You've got to subtract that 52 over and then divide by the negative 48. So that's what we're going to do. What is 9 minus 52? So we've got negative 43 equals negative 48 cosine of A. And so then we're going to divide by negative 48. So 43 over 48 is cosine of A. And how are we going to find that angle measure A? Inverse cosine of 43 over 48. Can we go 1 decimal place with that? What do we end up getting? 26.4. Again, make sure you're in degree mode for these. I know some of us were not earlier, so if you are not in degree mode, get in degree mode now. So we know that A is 26.4. We're going to do the same process to find our next angle. It really doesn't matter which one you want to find. Do you want to do B or C? B? I think B makes sense just because B comes after A. So we'll do that one. And then once we have 2 angles, we can just subtract from 180 to find our 3rd angle. So you don't necessarily have to do law of cosines again. Does that make sense? So we're going to do the exact same thing. If you're looking at your rules up top, we're using the second one now because you're trying to find angle B. But basically, we're just going to take side B, which was 4, and do 4 squared equals the other 2 sides squared. So 3 squared plus 6 squared minus 2 times your other 2 sides, which was 3 and 6, and then cosine of B. So we'll go about solving that the same way again. So 4 squared is going to give us 16, and then we can do 3 squared plus 6 squared. What will that give us? 45. And then we can do 2 times 3 times 6, which is what? 36. Cosine of b. Then what do we do from there? Subtract that 45 over. Remember, we cannot combine the 45 and 36 there. So that's going to give us negative 29. So it's negative 36 cosine of b. Then divide by negative 36, then do the inverse cosine of that number. And what do we get for b? 36.3 degrees. Is that all right? Questions? How can we find our third angle? Just subtract from 180. So you could add these guys, subtract from 180, subtract them all. It doesn't really matter. When you do that, what do you end up getting? 17.3 degrees. Is that okay? And if we did law of cosines again, you would still get the same answer. Do you want to do that? Or are we good? No? Okay. So, if you were curious, it works out. But that's that. Questions? Yeah. You could. Now, most of the time that works, but I did run into one on the homework where it didn't. So if it's asking you to use law of cosines, let's stick with cosines. Does that make sense? And I'm not quite sure why that doesn't work out. I'll look into it, but if it's asking you to use cosines, we need to use cosines. Alright, we're gonna do the next one. So looking at number 2 on the bottom. I can't spell triangle. That should say triangle, not tribal. I don't know. I don't know what my deal is, but like I've been typing triangle a lot this week because like of our notes, and I have not spelled it right once, ever. It's not happened the entire time. Like I know how to spell triangle, but I can't type triangle. So this time they're telling us that angle C is 60, side A is 2, and side B is 3. So when we saw this, it's going to be a little bit different. So since we have side A and B in angle C, we could use this formula to find side C. Does that make sense? So it's actually going to be fairly easy because we can type it straight into our calculator essentially. So to find side C, we're going to say C squared equals the two sides that you do have. So 2 squared plus 3 squared minus 2 times your sides, which was 2 and 3, times cosine of your angle, which was 60. And you can literally type that straight in the calculator. So fairly easy. You could simplify it one piece at a time if you wanted to. What do we end up getting for C squared? 7. So then what is C going to be? Square root of 7. Is that okay? Alright, so now that we have side C, we can find another angle. We'll use law of cosines again. Do y'all want to find angle A or B? Let's do A. So we'll try to find angle A. So if you're trying to find angle A, that means we're going to put side A on like the one side of our equal sign. So we'll say like 2 squared equals. Then we'll have 3 squared plus root 7 squared, because those were our other two sides, minus 2 times 3 times root 7 times cosine of A, and we don't know what that A is. We just talked about that. You could, and most of the time it works, but sometimes it doesn't. So if you're starting with law of cosines, we probably need to stick with law of cosines. Yeah, sure. Like I said, most of the time it works, but there is one on your homework where it doesn't work. So I just want to be sure that we get it all the time. 2 squared is going to give us 4, and then 3 squared plus root 7 squared is going to be 16, minus 2 times 3 times root 7 is 6 root 7. cosine of A. What do we do from there? Minus 16, so that's going to give you negative 12 equals negative 6 root 7 cosine of A. Then divide by negative root 7. So I just went ahead and got a decimal there, and it's like 0.76 cosine of A. And then you'll do inverse cosine of that number to get the angle measure A. And what do we end up getting? It does here, but it's not squared here. $40.9 for that angle?
Yeah.
0.9? That's what I got. If you rounded, then it might be a little bit different. Does it not come out like that? I have 12 over 6 root 7. 0.75. So I did I just went ahead and did inverse cosine of that number. Does that make sense? Yeah. Okay. So if you round differently, so I put 0.76 here, if you do inverse cosine of 0.76 instead of 0.7 blah 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 all this other stuff, it's going to be a little bit off, and that's okay. I'm not going to count you wrong for that, but just be aware of that. So I try to pull the answer and not type in rounded answers for my steps through. Does that make sense? So it might be a good idea to try doing that as well. So we still need to find angle B. How could we do that? Just subtract from 180, right? So you already have 60, and then we got 40.9. So when you subtract all those from 180, what do we end up getting? 9.1. Is that okay? Questions? So that's basically all there is to it. There's not any of the whole ambiguous cases like we had yesterday where you could have more than one triangle, so you don't have to worry about that. That's pretty much it. We all right? Okay, so let's try some more problems. So for this one, we've got a motorized sailboat. It's leaving Naples, Florida, bound for Key West, 150 miles away, maintaining constant speed of 15 miles per hour, but encountering heavy crosswinds and strong currents. The crew finds after 4 hours that the sailboat is off course by 20 degrees. So you've got your nice little picture over here showing you that. So how far is the sailboat from Key West at this time? So that wants us to find this side right here. So we know that they've traveled, I guess I told you. Yeah, 60 miles this way, 150 miles this way, and we know this angle. So you could find your missing side. So that's like we did before on which one? Where you had the two sides and the angle in between. Right here, where you had your two sides, the angle in between. So we're going to set this one up just like that. So if we're trying to find x squared, or just x, we'll have our sides that we do have squared. So 60 squared plus 150 squared minus 2 times your sides, which was 60 and 150, all times cosine of the angle that you do have, which was 20. Are we okay with setting that up? Do you know where that stuff came from? Yeah. We're just pulling all that information from the picture that they gave you. So you can type that straight in your calculator. And then for x squared, we end up getting something like 9185.53. So then x is going to be like 95.8 miles. Questions on that? So that's just typing this straight into the calculator and then taking the square root. We all good? So looking at the next one, it says, through what angle should the sailboat turn to correct its course? So that's the angle that's measured or labeled A on your picture. So if we want to find angle A, we have all our sides at this point, so we can use your log cosines from there. So go ahead.
The angle of asking, wouldn't that be like the theta there?
It would be the theta there, but we don't know anything about theta. So we're going to find A and then subtract A from 180, and that's going to give us theta. Does that make sense? So we want theta, but we've got to find A to get there. Yeah? Okay. So to find A, because that's the one that's like inside of our triangle, we're going to use all of our sides, and then it's going to be cosine of A. So the side that's going to be on the other side of the equal sign is that 150, because it's across from the angle that we're trying to find. Yeah? So we'll have 150 squared equals our other side squared, so 60 squared plus 95.8. Or pulling that 95.8 from the one that we just did. So you're all good to find A? Or do we need to go through this list together? Okay. So for angle A, you should end up having about 147.7. So it's probably just a rounding thing along the way, which is fine. As long as you're close enough, we're good. Is that okay? Are we good with getting here? Yes, no, maybe? If you do not get there, you need to say something. Alright, so and we know the angle A is 147.7, so that's this angle right here, which we said is fine, but we actually want to know theta. So to find that, I'm going to say, we want to know theta. So since A and theta are like along a straight line, we can just subtract from 180. So we'll do 180 minus whatever A is, that's going to give us theta. Give me a second. So the angle that we really want there, that theta angle, is 32.3 degrees. So that's the angle that they need to turn to get back on course. Questions? So the last part there, it wants to know how much time has been added to the trip because they got off course, and we're assuming a constant speed of 15 miles per hour. So we need to figure out how many or how much distance was added because of this goof, right? So how far did they have to travel originally? What was it supposed to be? Supposed to be 150. How far did they actually end up traveling? Do we know? How do you get that? So this side plus this side, yeah? So if we do 60 plus 95.8, that's how far they actually traveled, which is 155.8. So it was 5.8 extra miles. So that's great. We know it's 5.8 extra miles, but how much time did that add to the trip? How can we figure that out? we kind of got to do like train tracks, right? So we know that it's 5.8 miles, and they're traveling at 15 miles per hour in 1 hour. Does that make sense? So we're dividing by 15. And so what do you get when you do 5.8 divided by 15? 0.3. I got 0.39. Yeah. And then again, just like we were saying yesterday, if we're like saying, oh, it takes 0.39 of an hour, does that make a whole lot of sense? So we need something that's going to make a little bit more sense than 0.39 of an hour. How can we do that? Multiply by 60, that's going to tell you how many minutes. So 0.39 times 60, what do you get? So 23.2 minutes. Questions?